Hello, welcome back. So let's talk about transitional depositional environments. These are the type of depositional environments we find between what we normally see on the continent, on land, as well as depositional environments that indicate more marine depositional environments. So this is kind of in between those two. Because it's in between those two, it kind of includes processes from both what we might see on land and in the ocean. For example, you get some deposition where a stream is flowing from land, the fluvial system, but it flows all the way into the ocean. And then it deposits material as soon as it hits the ocean. Moving water, once it slows down, will tend to deposit its material. So it deposits material in something called a delta. More on that in just a second. But then the deposit then is then later modified by the marine process, waves, and tides. Some transitional environments can include deltas, barrier islands and lagoons, and tidal flats. We'll talk about each of those. So a simple delta. So a delta is kind of similar to an alluvial fan. Alluvial fan is when sediment is brought out of mountains onto dry land by some sort of stream flowing water. Sediment comes out of mountains and flows onto dry land to form an alluvial fan. A delta is kind of the same thing, where you have a stream carrying sediment, but it's emptying out into water, and it forms a fan-shaped, triangle-shaped fan, and that is referred to as a delta. So simple deltas. Simple deltas are those that we have in lakes. They consist of a few different beds that are typical of these simple deltas, and as the delta builds outward, it progrades in a vertical sequence. Think how horizontal facies are the same order as what we see vertically. So they become coarser grained from the bottom to the top. So the bottommost bed may contain marine or lake fossils, where the top set beds contain more land fossils. So here's what we see. So again, these are simple deltas that we see streams flowing into lakes. All right. So we have again the bottom set beds, we have the foreset beds, and then we have the top set beds. So these layers are indicative, again, of simple deltas. You can't really see it off here, but this looks like obviously a very desert environment. Maybe northern Arizona, something you might see flowing into Lake Powell, something like that. The stream, it's intermittent, but when it does, it might come off here. In fact, it looks like this is the most recent area where the stream kind of comes down and then into this lake. But we can see the bottom set beds, the foreset, and the top set beds. Those aren't all too common. As what are more common are we getting into the oceanic-based deltas. So marine deltas rarely conform to the simple kind of threefold division, because there's a strong influence by some modifying processes within the ocean. When fluvial processes prevail, streams, a stream river dominated delta results. When there's strong wave action affecting the sediment, a wave-dominated delta forms. And when there's large and strong tides affecting the sediment at the delta, that's a tide-dominated delta. So here we have a stream, or sometimes known as a river-dominated delta. They have long distributary channels extending far out into the sea, meaning the stream is so powerful. The river is so powerful that it continues to push stuff. It continues to push stuff further and further out into the ocean. In this case, it's an example of the Mississippi River Delta in the Gulf of Mexico. The Mississippi River is so powerful, so much flow, it still continues to push stuff all the way out into what's now the ocean. So this is dominated by this stream or river process. It's still pushing things out and out and out, and the delta continues to grow and grow and grow. With wave-dominated deltas, they also have kind of a distributary channel, but the seaward margin, the end margin, is modified by wave action. So we get a lot of that sediment that is kind of deposited further out, pushed back in. So we kind of get this barrier island forming. It almost kind of pushes everything back into kind of a nice, neat shape if it's wave dominated. A great example of that is the Nile River Delta in Egypt. And then we have tide-dominated deltas. All of these have a kind of a triangle shape to them. Let me go back. They all kind of have, where's my mouse? All kind of have a triangle shape to them. But with tide-dominated deltas, they have tidal sand bodies kind of that are along the direction of tidal flow. So you can tell that the tidal currents flow into and out of this area in this direction based on the direction of these kind of sandbars. So strong tides coming in and coming out really kind of dictating the landforms here. This is in Bangladesh at the mouth of the Ganges River. I think it's the holiest river in the Hindu religion. I could be wrong. Barrier islands. So on broad continental margins where there's abundant sediment, like sand, you'll get these long barrier islands offshore, separated from the mainland by some sort of lagoon. In the U.S., barrier islands are common along the Gulf Coast and the Atlantic Coast. Texas in the Gulf Coast has some barrier islands. North Carolina off its coast in the Atlantic Ocean has some barrier islands. Many ancient deposits formed in this environment. Some sub-environments of barrier island complexes include grading of beach sand, dune sands that may contain fragments that aren't found, shell fragments that aren't found in desert sand dunes. And you can also get fine-grained lagoon deposits with marine fossils and bioturbation. That's the tunnels and burrows and trails that we see sometimes in sedimentary rock. The reason we get these finer grains deposited, smaller sediment material deposited in these lagoons, because these barrier islands made of a lot of sediment act as a barrier to the kind of high energy of the ocean on the other side. So it's much calmer waters in here. So if it's much calmer waters, then material can settle. You can get finer material settling in these lagoons. So that's why you get some muds and clays that could eventually turn to shales as opposed to sandstones of the barrier islands. Tidal flats. Tidal flats is another one, is present where part of the shoreline is periodically covered by seawater at high tide, but then exposed at low tide. If you've ever been to the beach, you know, if you go in the morning, the ocean might be right really close to you. You play around for a little bit, you go have lunch, you come back later in the day, and the ocean water is way further out. That's the tide at work. Tides on Earth, the whole ocean apparently seems to rise and fall periodically throughout the day all over Earth, and we have high tide and low tide. Some locations only have one high tide and low tide every day. Some have multiple high tides and low tides every day. So that's why if you've ever been to the beach, it looks closer at some points and further away at some points. So the tidal flats, again, are present where part of the shoreline is sometimes underwater at high tide, but then exposed at low tide. Many of the tidal flats prograde seaward, and they yield a sequence of rocks grading upward from sand to mud, so coarser at the bottom, finer grained as you go up. And one of the most distinctive features in rock cross sections is something called a herringbone cross bedding, or sets of cross beds that dip in opposite directions, and it looks kind of like this. All right, so we got high tides and low tides. They come in and out, come in and out, come in and out. and that the highest high tide only happens once every 14 days. The lowest low tide only happens once every 14 days, and then from there it's periodically. So you can get a few in the low tide area kind of coming in, coming out, coming in, coming out. And as we get higher and higher and higher, we start to get other material deposited. So again, this shows a fluctuation in water level, these tidal flats. So let's go ahead and pause here. So we've talked about depositional environments on land and how we can infer those of the past based on what we see in rocks now. We talked a little bit about transitional environments, and based on what we see in rocks now can tell us about those environments of the past. Now we're going to focus on marine depositional environments, and what we see now can help us figure out in the past if a particular area consists of sediment and or sedimentary rock that deposited in these ocean environments. So let's pause here, and I'll see you back here in just a second.